Okay, today I want to talk about the review for section 6.8, 7.8, and 11.1 today. So here, the first one, L'Hopital's rule. What's that? Suppose limit of f of x over g of x as x approach a is an indeterminate form of type 00 or infinity over infinity. So we can find limit values like this. Limit of f of x over g of x as x approaches a equal limit of f prime of x over g prime of x as x approaches a. If the limit on the right side exists, or infinity or negative infinity. So limit of f of x over g of x equals infinity over infinity form. The one important thing is that x value approaches infinity. So how can you find? So we use relative ratio growth. So we can use this table. So what does it mean? ln of x beta is growing faster than ln of x to the power alpha. X to the power p is growing faster than ln of x to the beta. X to the power q is growing faster than x to the power p. The a to the x exponential function is growing faster than any algebraic function x to the power q. The p to the x is growing faster than a to the x. The x to the x is growing faster than p to the x. This is called relative ratio growth. I'm going to give one simple example by using relative ratio growth in here. Could you answer my equation? This is equation. The limit x value approaches infinity. So we have square root of x over the ln of x to the power 100. What is answer? So do you know answer? Could you run your answer on the board? On the chatting board? So what is your answer of this question? So what is the answer of this question? The limit, the square root of x over ln of x to 100. Elisa said infinity. Is it right? Infinity? So here, you can change it. The limit, x value approaches positive infinity, top one is x to the 1/2, bottom one is ln of x to the power 100. So I want to use table here. ln of x to the 100 is here. The x to 1/2 is here. So which one is growing faster? X to the 1/2 is growing faster than ln of x to 100. Answer is infinity. This is the idea for solving this problem. You can try to solve one more problem. Limit x value approaches infinity. The 2 to the x over x to the 10 plus 5 to the power x. What is the answer? So what is the answer of this question? Do you know answer of this question? 2 to the x over x to the 10 plus 5 to the x. So what is the answer of this question? So Elisa said 0. Is it right? Is it right? So 0. So is it right? Is it right? So do you have another answer? It's good. The same idea. Here, x to the 10 is here. X to the 10. 10. The 5 to the x is here. What does it mean? 5 to the x is growing faster than x to the 10. You have to ignore slow one. You can compare 2 to the x, 5 to the x. Here, 2 to the x and 5 to the x by using here. This a is 2, b is 5. So 5 to the x is growing faster than 2 to the x. Answer is 0. This is the whole idea by using relative ratio growth. The next one, limit of f of x times g of x. This is like a typo, sorry. This is like x value approaches like a, the typo, sorry. The x value approaches a, f of x dot g of x is 0 times infinity. It's the same typo, x value approaches like a, f of x minus g of x is infinity minus infinity, the same. X value approaches a, f of x to the g of x is 1 to infinity, 0 to 0, the infinity to the 0. So how can you solve? Convert them to the quotient forms and then use L'Hopital's rule. This is the idea, or relative ratio growth. This is note. The limit of 1 plus a of x, b to the x as x value approaches infinity. So what happens? Here, x value approaches infinity, what happens? This is a of x is going to a over infinity is 0. This is going to 0. So b to the x is going to plus or minus infinity. Like b equals positive, positive infinity. B is negative, some the negative infinity. So what's the like answer of this question? This one is exactly 1 to infinity form. We have indeterminate form. So answer is e to the a times b. This is a simple one. So one more. Limit 1 plus ax to the b over x as x approaches 0 is same answer, e to the a times b. This is like a question. So what is the answer? What do you think? Do you know answer of this question? So what is the answer of this question? Do you know? E to the negative 15? Is it right? Yes. Here, this is same to what? Exactly. Limit x value approaches positive infinity. 1 plus negative 3 over x to the 5 times x. In this case, the negative 3 is a here. This is negative 3. The p is 5. This p is like 5. So what's that? You can use this rule, e to the a times b. E to the negative 3 times 5. Answer is e to the negative 15. Yeah, this is answer by using these two formulas. This is the idea like this. So next one. Let me see. So this is indeterminate form. The indeterminate form of this one. The indeterminate form. What's like indeterminate form? We have 0 over 0 or infinity over infinity. So this is like 0 over 0 or infinity over infinity. Is it right? Is it right? So 0 over 0, 0 over 0. So yes, it's good. You can plug. You can plug x equals 0 into the numerator and denominator. So what's that? This is same to e to the 0 minus 1 over the cosine of 0 is 1 minus 1. Was it like e to the 0? E to the 0 is 1 minus 1 over 1 minus 1 is 0 over 0. Yes. This is indeterminate form of type 0 over 0. So we can use L'Hopital's rule. So like this. Here, take derivative top and bottom. So what's that? We have e to the 2x prime is, we can use chain rule 2 times e to the 2x. Negative 2x prime is negative 2. The 1 prime is 0. Here, cosine prime is negative sign, -1 prime is 0. So we have it. So you can plug 0 into top one and bottom one. What happens? 2 times e to the 2 times 0 minus 2 over negative sine of 0. So e to the 0 is like 1, 2 minus 2 over. The sine of 0 is 0, exactly 0 over 0 form. How can solve? We use L'Hopital's rule again. Okay. The same rule. You can keep 2 e to the 2x prime is 2 times e to the 2x. The negative 2 prime equal to 0. Negative sine prime is minus cosine. So 4 times e to the 2x over negative cosine. You plug 0 into top one and bottom one. The 4 times e to the 0 is 4. Cosine of 0 is minus 1. Answer is negative 4. This is the whole idea. The next example. X value approaching infinity. So what happens? X value approaching infinity. So what is it? This one. Infinity over infinity. Is it right? Yes. So 3 to the x is going to infinity. 4 to the x is going to infinity. 10 to the x is going to infinity, infinity, infinity. This is going to infinity. The infinity plus 1 is infinity. Infinity plus 5 is infinity. Exactly. Infinity over infinity. The x value approaching infinity, we have infinity over infinity form. So we use relative ratio growth. You can use table. This is like better. So how can you decide this kind of things? The first one. So you can decide which one is like the first one. You can change it, this one to the only one base. This is 4 square to the power x is 4 square is 16 to the power x. You can change it. So we have it like this. The next tip, I'm going to use a table. First, numerator. The numerator has the next one. Here, 3 to the x. The 16 to the power x. Here, ln of x to the 100. So which one is growing faster? We can use this inequality. 16 to the x is growing faster than any other terms. So you have to ignore lower terms. The bottom one. Bottom one has here. We have 10 to the x is exponential function. X to the 100 is polynomial. The 2 times x is x to the power 1 is here. So which one is growing faster? 10 to the x is growing faster than any other terms in the denominator. Ignore this one, and constant. So we have only 16x over 10 to the x. So we have it. The next, we can compare 16 to the power x, the 10 to the power x. The 16 to the power x is growing faster than 10 to the x. Answer is infinity. This is like a whole idea. Yeah. The next one. So you plug 1 into here. So what happens? So plug 1 into here. This value approaches what? This value approaches 1 to the 5 minus 1 is approach 0. What's ln of 0? ln is going to negative infinity. Same. 1 to the 9 minus 1 is like 0. What's like ln of 0? So this ln function approaches negative infinity. What happens? This is minus infinity minus negative infinity. Negative infinity minus negative infinity, exactly minus infinity plus infinity. So we have infinity minus infinity form. This is called like this, indeterminate form. So how can solve? Convert this one to the quotient. What is like a quotient? Quotient is like fraction. You can change it to the fraction. This is the idea. So this is like a difference is going to this fraction, limit ln of x to the 5 minus 1 over x to 9 minus 1. You can plug 1 into 탑은 바라본 plug 1 into x, plug 1 into x. What's that? 1 to the 5 minus 1 over 1 to the 9 minus 1 is 0 over 0 form. You have to use L'Hopital. The x to the 5 minus 1 prime is 5 times x to the 4. X to the 9 minus 1 prime is 9x to the a. So next, you plug 1 into x. So we have 9 times 1 to 4 over 9 times 1 to 8 is ln of 5 over 9. This is answer. The next one. You plug 1 into here, so what happens? So like this one. You plug 1, this value approaches. This one is sine of pi. Times, you plug 0, what happens x minus 1? This is approaches 0. What's like ln of 0? ln of 0 is going to negative infinity. What is sine of pi? Do you know sine of pi? Do you know sine of pi? So what is the sine of pi? Is it 0? Is it right? 0? Yeah, you can draw the graph. Graph is so like this. This is sine of x. Here, pi. This is 2 pi. So sine of pi is like 0 times infinity form. The 0 times infinity form. So indeterminate form, I can convert this one to the quotient form and then use L'Hopital rule. It's like the same idea. So you can change it to the fraction. Limit ln of x minus 1 over sine of pi x. You have to use identity. 1 over sine pi x is cosecant pi x. Next, you have to use L'Hopital rule. So what's like ln of x minus 1 prime and cosecant pi x prime? ln of x minus 1 prime is x minus 1 prime over x minus 1. So cosecant pi x prime is negative cosecant times cotangent times inner function prime. So simplify. The x minus 1 prime is 1. So here, the pi x prime is just pi. You can change. Cosecant pi x is 1 over sine pi x. Cotangent pi x is cosine over sine. And combine the minus 1 over pi. You can take out here, negative 1. And take out pi. Exactly, minus 1 over pi. Take out. The next, you can change this one to the like this one. How can you change? So this part is same to numerator is 1 over x minus 1 times the reciprocal of denominator sine pi x over 1 times the reciprocal of denominator sine pi x over cosine pi x. You can change. So like this. Next, combine. So what's that? This is sine square of pi x. So x minus 1 times cosine pi x. So we have this kind of form. The next, you have to split like this because you plug 1 into here. So what happens? Sine square of pi times 1 over 1 minus 1 times cosine pi times 1. What is sine pi? Sine pi is 0. 1 minus 1 is 0. Cosine pi is negative 1. So you have to split. The non-zero part, cosine pi x is here. So this is 0 of 0 form. The 0 of 0 form is here. Okay, the split. So like this. Next, distribute the limit. And calculate. You plug 1 into here, only cosine pi. So you have to keep second limit. Cosine pi is -1. So here, this is what? 0 over 0 form. You have to use L'Hopital's rule, right? You can use L'Hopital's rule. Sine 2 pi x prime is, you have to use chain rule twice. 2 times sine pi x times sine pi x prime over x minus 1 prime is just 1. The 1 over pi limit to sine pi x cosine pi x times pi x prime is sine pi x prime. The pi x prime is exactly pi. So this is 2 times pi is here. The remaining things, sine pi x cosine pi x is here. The next, plug 1. 1 over 2 times 2 pi, sine pi times 1, cosine pi times 1. What's the answer? The sine pi is 0. Cosine pi is -1. So answer is 0. 0. This is the whole idea. The next one. This one. This is indeterminate form. Indeterminate form or not? This is indeterminate form. Kevin said 1 to infinity. Yeah. X value approaching infinity. What happens inside 1? You calculate limit x value approach infinity only inside 1. 2x minus 5 over 2x plus 7. You have to ignore constant. The cross out 2x, yes, 1. So inside 1 is 1. You plug infinity into x. The 2 times infinity plus 1 is 1 to infinity. Yes, we have indeterminate form. The how many indeterminate form of the power form? So how many indeterminate form of power things? This one, like this. This is power form. How many indeterminate form of this one? Yeah, 3. Kevin said 1 to infinity. Do you know 2 more? 2 more? Yeah, 0 to 0. Okay, 1 more. 1 more. Yes, infinity to 0. We have only 3 indeterminate form of the power form. We have 3 things. So here, this one is 1 to infinity indeterminate form. So what's step 1? Take ln. The 2x minus 0 power is down, so like this. Step 2, take limit. Take limit over here, take limit. You can change fraction. Limit of ln function over the 2x minus 1 is going to denominator by using reciprocal. The next, you have to split. ln over top one. ln over 2x minus 5 minus ln over 2x plus 7. Next, we use L'Hopital's rule. ln over 2x minus 5 minus ln over 2x plus 7 prime over 1 over 2x plus 1 prime. So what's that? So this one is here. Limit x value approaching infinity. ln over 2x minus 5 prime is 2x minus 5 prime over 2x minus 5 minus ln over 2x plus 7 prime is the 2x plus 7 prime over 2x plus 7. How can you find the 1 over 2x plus 1 prime? You can use the quotient rule. 1 prime times 2x plus 1 minus 1 times 2x plus 1 prime over bottom 1 squared. 2x plus 1 squared. This is like a whole idea. So we have this one, like this. And simplify. The 2x minus 5 prime is 2. The 2x plus 7 prime is 2. So what's like the bottom one? The bottom one is 1 prime is 0 times 2x plus 1 minus 1 times 2x plus 1 prime is just 2 over, let's see, parentheses, the 2x plus 1 square. So this is same to 0 times 2x plus 1 is 0. The minus 1 times 2 is negative 2 over 2x plus 1 the square. So we have the denominator. The next, you have to simplify. You can use common denominator. The first one, you multiply top one and bottom one by 2x plus 7. The top one and bottom one by 2x minus 5, 2x minus 5. And combine. The 2 times 2x plus 7 minus 2 times 2x minus 5 over common denominator 2x minus 5 times 2x plus 7 over the negative 2 over 2x plus 1 and simplify. So like this is right. Distribute 2 4x. 2 times 7 14. The negative 2 times 2x is minus 4x. Negative 2 times minus 5 is positive 10. Over 2x minus 5 times 2x plus 7 over negative 2 over 2x plus 1 squared. The next, simplify. So here, 4x is cancelled. The 14 plus 10 is 24 over denominator, this one, times the reciprocal of denominator, the 2x plus 1 squared over negative 2. So simplify more. 2 is crossed out, only change 12. The negative 1 times 12 is the negative 12 here. The next, this is infinity over infinity form. You have to ignore lower terms. So you can keep negative 12, 2x squared over 2x times 2x. So 2x squared is crossed out, negative 12. This is not a final. So we have only this one. So was it like original problem? Original one doesn't have ln. So step 3, take e. Answer is e to the negative 12. That's it. This is the final answer for solving this problem. The next one, we are going to improper integral of type 1. Case 1, the integral a to infinity f of x dx. So how can you solve? You can replace infinity by t and take limit. Limit integral from a to t f of x dx as t value approaches infinity. So case 2, you don't have it, e to negative 12. Really fast? Okay, I can just slow down a little bit. Yep. The case 2, the integral from negative infinity to b f of x dx. The same. You can replace minus infinity by t. You can take limit. The t value approaches minus infinity, integral from t to b f of x dx. The improper integral is conversion. What does it mean? The limit exists. The improper integral is divergent if the limit does not exist. So third case, the improper integral from minus infinity to positive infinity f of dx. How can you solve? You can split two improper integral. Integral from minus infinity to a f of x dx plus integral from a to infinity f of x dx. What's integral from minus infinity to infinity f of x dx is convergent. So both improper integral from minus infinity to a f of x dx and integral from a to infinity f of x dx are convergent. Was it like divergent? So either one is divergent. So like this here. So was it like some of the limit exists? The limit value is finite. It's like meaning limit value is like finite. Was it like limit does not exist? You calculate limit and definite integral. This value is infinity minus infinity or oscillating infinity many times. Oscillating infinity many times. The improper integral is divergent. Was it like the last case here? The first one is convergent. Second one is convergent. What's the answer? So this one is convergent. Just like exact meaning, both convergent. The first one is divergent. Second one is convergent. What is the answer? Divergent. The first one is convergent. Second one is divergent. What is the answer? Answer is divergent. The first one is divergent. Second one is divergent. What is the answer? Answer is also divergent. This is like exact meaning of the improper integral of the last one. This is the last one. Here, improper integral of type 2, case 1, discontinuity at B. How can you find this one? So you can replace the discontinuous point B, replace discontinuous point B by T next to T value approaches B from the left. Why this is true? The next one. The exact thing is A and B. So you can choose T value. T value approaches B from the left. B from the left, so like this. Next, second case, discontinuity at A. The improper integral from A to B, f of x dx. In this case, you can replace discontinuous point by T. T value approaches A from the right. The Y here. This is A and B. You can choose T. T value approaches discontinuous point. In this case, from the right. You can use positive sign like this. Improper integral is convergent, same. The limit value exists. What does it mean? The limit is finite. The improper integral is divergent if the limit does not exist. Third case, discontinuity at A, C is between A and B. So like this, I can do that here. You can just split integral from A to C, f of x dx plus integral from C to B, f of x dx. How can you calculate integral A to B, f of x dx conversion? So both improper integral from A to C, f of x dx, and integral from C to B, f of x dx converge. Improper integral is divergent if either one is divergent. Either one is divergent. This is the exact definition of improper integral. So you can try to solve some problems together. Here. So I can do that. First, you can change it. It's like infinity. You can replace infinity by t. X e to the minus x dx and take limit t value approaches infinity. You can change it like this. Here. The next, How can you find integral x times e to the minus x? What kind of method is possible? The use substitution, integration by parts, the trigonometric substitution, partial fractions. So what's that? So what is a good method for solving integral 0 to t x to the minus x dx? Do you have any idea? So what kind of method do you want to use for finding this one? Kevin said U and dv, yeah, use substitution. Kevin said the substitution rule. So what do you think, other guys? Integration by parts? U dv is integration by parts. Sorry, Kevin. Yeah, Kevin, right? Yeah, integration by parts. Elisa said integration by parts. How about other guys? Are you agree? Yeah, they're like this. So you have to use integration by parts. How can you decide u and dv? This is idea. Do you remember? L-I-A-T, yeah, L-I-A-T-E. In this case, x is algebraic function, e to the minus x is exponential function. In this case, you can choose how you want is like u. U is x. dv is the remaining part, e to the minus x dx. You have it. The next, find du. The du is x prime dx. So we have du equals 1 times dx. What's it like a v? What's a v? Do you know what is a v? Minus e to the minus x, is it right? How can you find the v? You can calculate integral e to the minus x dx. How can you find the integral e to minus x dx? We can use this rule. Integral e to the kx dx is 1 over k e to the kx plus c. This is idea. So here the v is 1 over the k is negative 1 e to the minus x. Answer is negative e to the minus x. It's like a v. This is v. So we have what? U equals x. So du equals tx. The dv is e to the minus x dx. The v is minus e to the minus x. What's like integration by parts? Integration by parts is u times v minus integral v times du. What's like u times v? Like this diagonal. U times v is x times e to the minus x. So x times negative e to the minus x. Minus integral, the v du is v times du, bottom one. The v is negative e to the minus x dx. So simplify. Same to negative x times e to the minus x. You can change positive sign plus integral e to the minus x dx. Right? What's that? I missed one thing. This is like 0 to t, like 0 to t, 0 to t, the same here from 0 to t, from 0 to t. Here, this is same too, from 0 to t and 0 to t. This is like a whole idea of this integral. So we have like this. So this is my explanation. So next, you plug t into here. First, exactly the negative t times e to the negative t minus. You plug 0 into x, the negative 0 times e to the negative 0 is like first part. The change, this one is what? Negative times negative is change positive. This is plus equal e to the minus x from 0 to t dx. And simplify. This is what? Negative the t times e to the negative t. The 0 times e to 0 is just 0. You don't need it. Find antiderivative again. Equal e to the minus x is negative e to the minus x from 0 to t. The next plug number negative t times e to the minus t minus you plug t into x e to the minus t minus plug 0 negative e to the negative 0. So what's that? This is, you can change it to the fraction. They have t over e to the t minus 1 over e to the t. E to the 0 is just 1. The negative 1 times negative 1 is positive 1. So we have this result of this integral here, like this. What's like the next one? You can take limit. Take limit. T value approaches infinity. Take limit. The t value approaches infinity. It's like the last step. Take limit, like this. So what is the limit of t over e to the t? What's the limit of t over e to the t? What's the first one? Kevin said 0. So what do you think, other guys? Is it right? The 0? 0 is right? 0 is right. So here, limit t value approach infinity. You think about t over e to the t. Which is growing faster? Exponential function is growing faster than t. Answer is 0. So this is going to 0. This is also going to 0. Final answer is 1. So what does it mean? The improper integral is conversion to 1. It's like idea. The second one. The second one. So what do you think? How can you solve the second one? So in this case, what's the domain? 3 to 7. Domain is 3 to 7. I want to choose number 5. Choose 5. The 5 is between 3 and 7. 5 is between 3 and 7. So you plug 5 into function, exactly 1 over 5 minus 5 cube. This is 1 over 0. What does it mean? Undefined. Undefined. So what happens? The function f is discontinuous at 5. Here, function f is discontinuous at 5. At 5. So you have to split integral from 3 to 5, 1 over x minus 5 cubed dx plus integral 5 to 7, 1 over x minus 5 cubed dx. So first, you calculate this improper integral first. You have to use u substitution. So what's u? And solve this equation. What's u? So what's u? U is x minus 5. That means that x minus 5. Yep. Fine. du is x minus 5 prime is just 1. 1 times dx is just dx. you can change. Limit t value approach 5 from the left. You can replace discontinuous by t, and t value approach is 5 from the left, 1 over x minus 5q. The next, use u substitution. So we have this result because you can replace x minus 5 is u. You plug u into here. This is u. The next one, you can change it, dx is du. Plug here. Another one, you plug 3 into here. Fine, g of 3. You plug t into g of x, g of t. You can change the lower limit, upper limit. So what's that? What is g of 3? G of 3 is plug 3 into x. The 3 minus 5 equals negative 2. What is g of t? You plug t into this x, we have t minus 5. So next, the 1 over u cube is u to the negative 3. Find antiderivative by using power rule. The limit t value approaches 5 from the left. The integral u to the negative 3 is 1 over the negative 3 plus 1 u to the negative 3 plus 1 from negative 2 to the t minus 5. You can just simplify. So this is u to the negative 2. You can change it 1 over u square here. So this is the same to the minus 1 over 2. So we have it minus 1 over 2. The next, plug t minus 5 and negative 2. So what is the answer? What is the answer? So what is your answer of this limit? The last one. What's that? Divergent. Because you can plug infinity things 5 into here. What happens? Minus 1 over 2 times 5 minus 5 square. This is minus 1 over 0 undefined. We have two possible answer, infinity or minus infinity. 1 over 0 minus, not times, 1 over 8. This is negative. 1 over 0 minus 1 over 8. So here we have negative infinity. So series is divergent. So that's it. Limit does not exist. This is the reason. How to check if a sequence converges or diverges. This is like a section 11.1. Theorem. Limit f of x equals L as x approaches infinity. F of n equals a sub to n. N is an integer, then limit of n approaches infinity n is going to L. Does it make sense? Example is like this. So f of x is, you can solve this problem. X value approaches infinity, 1 over x. What is the answer? So do you know answer of this one? Yup, 0. You can replace x by n. Limit of n approaches infinity, 1 over n. What is the answer? Answer is, yes, same 0. This is idea. The limit of f of x is L. The limit of an is also L. We have same result. Is it true? The limit laws for sequence. So if sequence an and sequence bn are convergent sequences, C is a constant. The first one, limit of an plus bn is, you distribute limit. Limit of an as n approaches infinity plus limit of bn as n approaches infinity. The limit of an minus bn as n approaches infinity. So same, distribute, limit of an as n approaches infinity minus limit of bn as n approaches infinity. The limit of c times an, you can take out c, the c times the limit of an as n approaches infinity. limit of C. What's the limit of C? Do you know answer of this one? What's the limit of C? Means that C is right. C is it C? Yep. Yep. This is right. The limit of constant is constant. 5 and approach infinity is yes. Constant function doesn't change. So C. Limit of an distribute. Limit of an times limit of bn. Limit of an over bn distribute. In this case, bottom one is non-zero. You can use this rules. Limit of a n to the power p. The limit is inside the base. P is greater than 0. A n is greater than 0. Like limit laws. So do you know squeeze theorem? So like this. The Pn is between A and Cn. Limit of An, limit of Cn equal to L. What happens in middle one? Also equal to L. This is true. So because I want to use this inequality first. You can take limit each side. Inequality doesn't change. What's like limit of An? The limit of An is L. Here, what's the limit of Cn? Limit of Cn is L. So what's the conclusion? The limit of middle one, Pn is between L and L. Same number. So what's the limit of Bn? Same number L. So we call squeeze theorem. Squeeze theorem. So what's the application? Limit of absolute value of An equal to 0. The limit of An is also equal to 0. So indeterminate form and L'Hopital's rule, the limit of An over Bn and n approach infinity is infinity over infinity, 0 over 0 form. You can use L'Hopital's rule. This is ideal for solving sequence problem. The limit of An times Bn, the 0 times infinity form. The limit of An minus Bn as n approach infinity is infinity minus infinity form. Limit of An to power Bn form, 1 to infinity, 0 to 0, infinity to 0 form. You have to convert this form to the quotient, like a fraction form, and then use L'Hopital's rule or relative ratio graph. This is the idea for solving sequence problem. So one note, the limit of 1 plus a of n to b times n is e to the ab. So one more. Do you know relative rate of growth? This is also possible. Limit f of n over g of n is infinity over infinity form. You can use similar table. The ln of n to power alpha is the growing slower than ln of n to beta. So was it like n to p, ln of n to beta? N to p is growing faster than ln of n to power beta. The n to q is growing faster than n to power p. The exponential function a to the n is growing faster than any algebraic function n to power q. The b to the n is growing faster than a to the n. So really be careful. One more here. The n factorial is growing faster than any exponential function. Last one, n to power n is growing faster than n factorial. We have relative ratio growth. This is a problem. Determine whether sequence converges or diverges. What is the answer? So what is the answer? Sequence, this sequence is converge or diverge. Conversion, you're right. What's the conversion number? E to the negative 10, is right. You can take a limit of sequence. In this case, the 2 equals A. The minus 5 is like B. Exactly. E to the 2 times minus 5 is E to the negative 10. We have a finite number. This is conversion. This is answer is converges to E to the negative 10. This is answer. So second and third one. What happened to the second one? The second one is converge or diverge. Second one is converge or diverge. Converge. What is the conversion number? So what is the conversion number? Conversion number is 0. Here, I can use this one. Limit of absolute value of an is going to 0. The original one is also going to 0. I want to use this one. Take absolute value of sequence minus 1 to power n over n squared plus 5. The minus 1 to n is gone. You have to ignore this one. So next, this is like infinity over infinity form. You have to ignore constant term. So we have it. The cross out and 1 over n is going to 0. That's it. This is the answer. So answer is sequence converges to 0. This is the answer. The next one, 0. Next, here, the sequence is conversion or diversion. What is the answer? What is your answer? Oh, this one, conversion or diversion. Conversion? Diversion? What's that? Diversion? Means that diversion? So let me see. Here, limit of n squared over n squared. We can think about only positive one first. You have to ignore lower terms, the cross out, answer is 1. What is to happen? Take minus 1 to n. What happens? This is does not exist. What does it mean? So here, what is minus 1 to n? You can just sketch the graph, this one. So this is 1. This is minus 1. This is 1. You can plot A1. A1 is minus 1 to 1, 1 square over 1 square plus 5. Exactly here. You can plug A2. You plug 2 equals n. So here 3, A4, A5, A6, A7, A8. What happens? This is oscillate. So what happens even part? Even part A2, A4, A6, A8, like choose even part approach to 1. You can choose odd part. A1, A3, AQ, A to the 5, A to the 5, the A to the power 7, A to the power 9. What happens? Approach to negative 1. Just oscillating infinity many times. Limit does not exist. Limit does not exist. Sequence is divergent. This is the idea. Here, the sequence is convergent or divergent. So what do you think? Convergent or divergent? What do you think? This one. So how can we solve this problem? So we have conversion. Elisa said conversion. So like this. So we don't have a cosine and pi. Just the sequence is the inverse tangent of n is like given. You can take limit. N approach infinity. What happens? Inverse tangent of n. N is approaches positive infinity. Inverse tangent of infinity is your right, pi of 2. Answer is converges to pi of 2. This is the answer. But what happens cosine n pi? Cosine n pi is like alternating sequence. So what does it mean? Here, what's cosine n pi? You plug 1. What's cosine pi? What's cosine pi? Minus 1, minus 1, minus 1. Yeah, this is minus 1. You plug 2. What's cosine 2 times pi? Yeah, cosine 2 pi is 1. This is minus 1 square. Cosine 3 pi is minus 1. Minus 1 cube. Cosine 4 pi is positive 1. Minus 1 to 4. We have this pattern. Cosine n pi is minus 1 to power n. So you have to replace. You can replace. Cosine n pi is minus 1 to power n. You plug into denominator here. Minus 1 to n. Inverse tangent of n. This is exactly same to, it doesn't matter. This is going to here times inverse tangent of n. Go like this, right? So I just said before, positive part approaches pi of 2. What happens? This one, this is same to minus 1 to n, inverse tangent of n. This is does not exist. So similar ideas. Here, pi of 2. Here, negative pi of 2. You can plug. You plug 1 into here, minus 1 to 1, inverse tangent of 1 is negative pi of 4. A2, A3, A4, A5, A6, A7, what happens? The oscillating infinity many times limit does not exist. So sequence is divergent. This is the idea. The next one. This is the first one. This is a convergent or divergent. You can calculate limit of nth root of 5 to the power 1 plus 2n. What is the answer? Convergent or divergent? So what is the answer of this question? Convergent or divergent? What is the answer? The limit nth root of 5 to the 1 plus 2n. What is the answer? So what is the answer? 0? 0? Approach to 0? You're right? Approach to 0? Is right? Approach to 0? So let me see. Approach to 1? Is 1? Is 1? 1? Sorry, no. Can I show to you? Here. You can change it to the power form. 5 to the 1 plus 2n to the power 1 of n. The next distribute is right. So distribute 1 of n to the 1 and here 5 to the 1 of n plus 2 exactly 5 square. So we have 25. 25 is 25. This is not infinite to the 0 form. Yeah, infinite to 0 form is right, yes. But this is a little bit different. Yeah, you can use this kind of things. So when you have the 1, this is the next one. We think about this problem. Nth root of 5. Is it converge or diverge? What do you think? Nth root of 5 converge or diverge? This is same idea. Take limit nth root of 5 same to limit. Nth root of 5 is 5 to the 1 over n. So what happens? N is going to infinity. This is 5 to the power 0. Answer is 1. Answer is conversion to 1. This is idea. Really be careful. You can change radical form to the exponential form and calculate very carefully. Very carefully. The second problem, we use relative ratio growth. You can use it. Natasha said the root test, no. Why not? Because this is not a series problem. This is sequence problem. You understand what I mean? This is not a series problem. So problem is summation n equal to 1 to infinity, 5n plus 1 over 6n plus 2 to the power n is given. Question is converge or diverge. In this case, series. Yes, you have to use root test. Don't worry, Natasha. This is a good question. So really be careful. The series problem, sequence problem, totally different. You have to use set notation. This is sequence. We have summation notation. This is a series. This is totally different. So really be careful. These are two kind of things. So we are going back to this problem again. How can you do that? Here, first one. 3 to the n is here. 3 to the power n. A to the power n is here. N to the 100 is here. So what is it like inequality? So like this. A to the n is growing faster than other terms. You have to ignore slow one. Next one, n factorial is here. Another one, adding up n to the 1000 is here. Adding up n to the 1000. So n factorial is growing faster. Ignore. Only choose n factorial and 8n. So like this. Next, compare. So n factorial is here. A to the n is here. N factorial is growing faster than a to the n. Answer is 0. This is 0. This is the idea. So sequence is conversion to 0. Right? The next one. Top one. How can you solve this one? So do you know this one? So 5 factorial is 5 times, 4 times, 3 times, 2 times 1. Same. Don't use a ratio test. This is not series. Sequence. So summation n equal to 1 to infinity. Yeah, infinity. 2n plus 1 factorial to the power square, the 2n plus 2 to factorial, 2n factorial things. In this case, yes, you have to use ratio test because this is like a series. This is sequence. Sequence. The sequence. So don't use ratio test. Don't use any test. For series, don't use any test. Only calculate limit. This is ideal. Just to calculate limit. But anyway, going back to here, the 5 times 4 times 3 times 2 times 1 is same to 5 times 4 factorial, change it like this. Or 5 times 4 times 3 factorial. This is like idea. So here, you can change it. The 2n plus 1 factorial to the 2n plus 1 times 2n factorial. The 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial. The last one, 2n factorial is here. The next is distribute 2. Distribute 2. The 2n plus 1 square. 2n factorial square. The 2n plus 2 is here. The 2n plus 1 is here. The 2n factorial times 2n factorial is 2n factorial squared. The next is cross out 2n factorial squared. We have limit 2n plus 1 squared over 2n plus 2 times 2n plus 2. So yeah, you're right. So here, ignore constant 2n squared over 2n times 2n. So cross out, answer is 1. What is the answer? Converge to 1. This is answer. Second one. How can you do that? You can change it to fraction. The ln 5n squared plus 2n plus 1 over 3n squared plus 5n plus 10. So what is like the next one? You have to ignore lower terms. So we have it. Cross out n squared. Answer is ln of 5 over 3. Okay. So last sequence is conversion to ln of 5 over 3. This is like a whole idea. Okay, this is some all today lecture review for L'Hopital's rule, relative Rachel growth, improper integral, and sequence problem. Some on Thursday, Kasha covers series problem, all series problem from the Kasha. Okay, that's all of today class. So do you have any question? If we have any question, only write on the chatting board. I will answer your question. Yeah, I'm just waiting. So, yep.